Okay, this is going to be a demo of a blockchain cryptocurrency that I wrote, and I'm going to just demonstrate how it works and different features of it. There's a full-length article that goes with this demo, and the link is in the description below. I'm just going to cover here what we're gonna go over in the demo. So there's going to be three users and a miner. So user 1 is going to be on port 3001, user 2 on port 3002, user 3 on port 3003, and there's going to be a miner that's only going to be responsible for mining new blocks to the chain, and that's going to be on port 3004. And this is all going to be more obvious, like when I do the demo, we're going to be using Postman for the demo. All right, the demo itself is going to be just doing some cryptocurrency transfers between users. So we're going to show how the blockchain is replicated between users and how one user can send cryptocurrency to another user. And also we're going to cover how when new users join the blockchain network, how they automatically get a copy of the blockchain that's on the system. We're also going to be covering new blocks and showing that new blocks are being mined by the miner, and also getting the wallet balances of each user. This is a summary of what we're going to demo. So there's going to be the three users and the miner, and every user is going to start off with 500 tokens or balance in their wallet. And what we're going to do is we're first going to just do a very simple transaction. We're going to send user 1 sending 100 cryptocurrency to user 2. So after that, we expect user 1 to have 400, user 2 to have 600. And the miner, because he did the mining, he gets a reward of 10 tokens. We're then going to have user 3 join the group or the network. Now, up to this point, user 3 is not part of the network. So user 3 will then join the network, and then we're going to show how they get a replica of the blockchain. So that way, you know, any new users can join at any time. It's not like they have to be there at the beginning. Then we're going to show user 2 giving 25 currency to user 1, and then 75 to user 3, and then also user 3 giving 10 to user 1. Now, these transactions are going to be different from the first transaction, this one over here, because these three transactions will actually not be mined until they're going to be mined sort of together. So that's just going to show that the mining process is very important, because before those transactions are mined, the users will still have their old balances, which are here. They're still going to have 400, 600, and 500 for user 3. But only after the mining is done, that's when you're going to see the update to the balances here. So user 1 is going to end up with 435, user 2 with 500, and user 3 with 565. And the miner is going to have 520 because he's going to be rewarded again another 10 currencies for the second time that he mined a new block. All right, so this is the Postman web API tester, and I've set it up to have a lot of the web API calls here as saved. So I'm just going to bring some of them up just to show you how the blockchain currently is working. So right now there's three users that are active. There's user 1, user 2, and the miner. So what we can do is we can first check the balance of each one. So here's the API call to get the balance, and we're going to do it for port 3001. That's the user 1. So here we can see they have 500. Then we're going to change this to user 2, and it's 500, and then 3004 is 500. If we do 3003, he's not in the network yet, so it's going to show like there's nothing there, so it's going to be undefined. There's no response. So there it is. It couldn't get any response. Okay, so now we have those three users right now with 500 balance for each one. All right, so what we're going to do now is we're going to transfer some currency from user 1 to user 2. And we're going to transfer 100 tokens. So for that, we need the address of user 2. So that we're going to get from the public key endpoint. So right now, we're going to set it up to get the public key of user 2. When we do that, here's the public key of user 2. We're going to copy that. And now we're going to call the transact endpoint, which is here. And I've already got it pre-configured for the body. So we're just going to put in the real address, which is user 2's. And we're going to say we're going to transfer 100. And that's it. So 3001, so this is user 1 doing a transaction of 100 cryptocurrency tokens to user 2, and let's send that. Okay, and here we can see the response. So here we can see that these are the two transactions right here. So this is the 100 that was sent to user 2, and this is actually what's left over from user 1. Now this is actually a pending balance because this has not been mined yet. This is sort of in pending state. But we could see here that the transactions did go through. So now it's going to be time to mine the transactions. And to do that, we're going to call the mine transaction endpoint, which is here. And this is going to be done by the miner who's on port 3004. So all we need to do, sorry, let me just back up for a second. Just to show what the current situation is, we're going to see what the current blockchain is for the users. So the current blockchain, before we mine those transactions, I just want to show that the current blockchain only has the Genesis block. So if we do, so we have the block. So this is what user 1 sees as the blockchain. So here we see that user 1 only has the Genesis block, and user 2 has only the Genesis block, and user 4, which is the miner, they only have the Genesis block. So right now the blockchain is only one block, and the transactions that we just so right now they haven't been added to the blockchain. And again, we can see that in this endpoint here, transactions. So if we look at the transactions, every node on the network should have a copy of the transactions, but they haven't been mined yet. So this is user 1. They have this transaction. That was the transfer of 100 to user 2. But user 2 also has those transactions, and user 4 also has those transactions, or the miner rather. So there we go. So everybody has a copy of the transactions, everybody has a copy of the blockchain, but the blockchain is still only one block, which is the Genesis block. So now we can actually mine the transactions, and that was here. So if we call this by the user, by the miner, which is port 3004, now the miner will do the work of actually adding the new block to the blockchain and doing the proof of work that's part of the mining process. And again, to see all the code behind this, I would just refer you to the article, and there's also a GitHub repository that you can reference for that. Okay, so let's do this. So they mine the transaction. Okay, so after they mine the transaction, there's a call to get the blockchain again, and now we can see there is a new block on the blockchain. This is the Genesis block here, and then this is the new block. All of this that's the new block. All right, and here we could see that there was 100 delivered to user 2 by user 1, and also there was a 10 token reward transaction that was rewarded to the miner. So this is the miner on port 3004, he got 10 as well. So he got 10 tokens for mining that transaction. And now if we look at the balances, so what we should see now is user 1 should now have 400. So there it is, 400. User 2 should now have 600. So there's 600. And the miner should have 510 because he was rewarded 10 for mining the transaction. That's 3004. And there it is, 510 for the miner. Okay, so that, oh, sorry, one more thing I'm going to show, and that is the transaction pool, and that's what we were looking at before. Before they were mined, they were in the transaction pool. It's now empty because after they've been mined, there's no more transactions in the pool. So let's do transaction pool. It's empty now, and this has been replicated in all the nodes. So this is for the miner. His copy of the transaction pool is empty, but so should user 2's copy is also empty, and user 1 is also empty. So now we can see the transaction pool is empty, the new block has been added to the blockchain, and everybody's balance has been adjusted. Okay, that covers the very simple scenario, and now we can do a more complicated scenario involving multiple transactions to multiple users. Okay, going back to our demo scenario. So now we've done this part here. We've transferred 100 from user 1 to user 2. Now we're going to start up user 3, and they should start off with 500 balance. And then we're going to transfer 25 to user 1, 75 to user 3. This is all by user 2. And then we're going to transfer 10 to user 1. And then we're going to mine those transactions. So all these 3 transactions will be done first they'll be sort of added to the transaction pool, but then they'll be mined all together. Okay, so let's start up user 3. So we're going to go back to our command prompt. This is the command prompt for user 3. The other 2, they're running, and then the miner's running here. So now we're just going to start user 3 there. And now we're going to go back to our to Postman, and we're going to just review the balances. So this is the balance for user 1 on port 3001. So they have 400. User 2 has 600, and now let's try user 3. So there they go. So there, he's active, and they've got 500, and then user 4, which is, sorry, the miner on port 3004, they should have 510, and then here it is, 510. Okay, now we can also check that the new user, who is user 3, that they have a copy of the blockchain because they just joined the network. So let's go back to here, and this is now for user, for the miner, so let's just check that they have all the blocks, and they do. Okay, and now we can check that user 3 has all the blocks, and they do. Okay, and then we can check that user 2 has all the blocks, and user 1 has all the blocks. Okay, so every node right now has all the blocks in the blockchain. Everybody's balance is correct. And now we're ready to do the next transaction. Okay, now we're ready to transfer 25 tokens to user 1 by user 2. And what we're going to do is we need to get user 1's public key. So we're going to go back to Postman, and we're going to get the public key of user 1, which is here. So we're going to copy that. Then we're going to use the transact endpoint, which is over here. And now we're going to paste user 1's public key, and we're going to give them 25 tokens. And there we go. And now if we look at in the response, so we can see that 25 tokens have been sent to, the transaction has entered into the transaction pool. So they actually haven't been sent yet because we haven't mined the new block, but we can see the new transaction here. Now we're going to send 75 tokens to user 3. So now we need user 3's public key. So we're going to go back to the public key endpoint here and put in 3003. Here's the public key. We're going to copy that and then go back to the transact endpoint, paste in user 3 and make it 75 and send that. And now we can see that, so these are the two transactions here. They're in the pool, they haven't been mined yet. So the last transaction we want to do is we want to send 10 tokens to user 1 by user 3. So if we go back to the public key endpoint and put in user 1's URL, and then there it is, the public key of user 1 is here. Then we copy that, and now we're going to do a transact endpoint, which is here, but now we're going to do it from user 3, so that's port 3003, and the body we're going to paste user 1's public key, and we're going to set it to 10 tokens. So we'll send that. And if we look at the response, so there it is. There's the 10 tokens to user 1 by user 3. All right, so we haven't mined any of these transactions yet. In fact, if we if we go back to the balance endpoint and we check everybody's balance, they should be exactly the same as they were after the last mining operation. So now we're going to just check the balances before we mine the transactions. So if we go to user 1 and we check the balance, so it should be the same as before, which is 400. That was what it was after the last block was mined. And then user 2 should still be at 600. User 3 should still be at 500, which is what they started with. And the miner should be at 510 because he only mined one block. So now we have all these transactions in the pool, which are here. So here we have we have 25. So we have user 2 sending 25 to user 1, 75 to user 3, and then user 3 sending 10 to user 1. That's right over here. Okay, and now if we mine the transactions, just over here, and this is done by the miner. Okay, now let's see if we should have another block. So this should be our third block, which is right over here. All right, and now if we check, again, just to, one more thing, just to show here, the miner got another 10 reward. So let's go back and check our balances. So now, if we go back to our demo here, so we should see 435 for user 1, 500 for user 2, 565 for user 3, and 520 for the miner because they got rewarded for the second block that they mined. So let's check the balances. User 1, 435. User 2, 500. User 3, 565. And the miner is at 520. And there you go. So that was the blockchain with the balances showing correctly for all the users. And one other thing, let me just go back to the block endpoint. So this will show the blockchain being replicated for all the blocks. So this is for user 1. So they have all the blocks here, and then user 2 should have the same blockchain. Again, they have that same blockchain. And then user 3 should have the same blockchain. And user 4, which is the miner, they should also have the same blockchain. And also, if we look at the transaction pool after it's been mined, it should be back to being empty. So if we look at the transaction pool here for user 1, it's empty. For user 2, it's empty. For user 3, it's empty. And for the miner, it's also empty. And there you go. A working prototype of a blockchain that can transfer cryptocurrencies between users.